Blockchain technology is a revolutionary concept that has gained significant attention in recent years. It serves as the foundation for cryptocurrencies like Bitcoin and has the potential to transform various industries beyond finance. So, let's dive into how blockchain technology works. Before starting, please subscribe to our channel. You are watching Actually Explain. At its core, a blockchain is a decentralized and distributed digital ledger that records transactions across multiple computers or nodes. Instead of relying on a central authority, such as a bank or government, to validate and authorize transactions, blockchain uses a network of computers to reach a consensus on the state of a ledger. Here's a simplified explanation of the key components and steps involved in blockchain technology. Distributed network. The blockchain network consists of multiple nodes, each maintaining a copy of the entire blockchain ledger. These nodes communicate and synchronize with each other to maintain the integrity of the blockchain. Transactions. Participants in the network initiate transactions, such as transferring digital assets or recording data. Each transaction contains relevant information, such as the sender, recipient, and the details of the transaction itself. Blocks. Transactions are grouped together into blocks. A block contains a collection of transactions, along with a unique identifier called a hash. The hash is a cryptographic representation of the block's content and serves as a digital fingerprint. Cryptographic hashing. The blockchain uses cryptographic hashing algorithms to create the unique hash for each block. This process converts the transaction data into a fixed-length string of characters. Any slight change in the input data would result in a completely different hash. Linking blocks. Each block in the blockchain contains a reference to the hash of the previous block, forming a chain-like structure. This linkage ensures the immutability of the blockchain, because altering a block would require modifying all subsequent blocks, which is computationally infeasible. Consensus mechanisms. Blockchain networks employ consensus mechanisms to agree on the validity and order of transactions. The most common mechanism is proof of work, where nodes compete to solve complex mathematical puzzles. The first node to solve the puzzle earns the right to add the next block to the blockchain. Other consensus mechanisms, like proof of stake and delegated proof of stake, have emerged as alternatives, requiring participants to hold or stake a certain amount of cryptocurrency to validate transactions. Security and immutability. The distributed nature of blockchain, combined with cryptographic hashing and consensus mechanisms, provides robust security and immutability. Once a block is added to the blockchain, it becomes extremely difficult to alter or tamper with the data stored within it, enhancing trust and transparency. Smart contracts. Some blockchain platforms, like Ethereum, support smart contracts. These are self-executing contracts with predefined rules encoded in the blockchain. Smart contracts automatically execute actions when specified conditions are met, eliminating the need for intermediaries in various contractual agreements. By leveraging these fundamental principles, blockchain technology enables secure, transparent, and decentralized record-keeping, ensuring the integrity of transactions and fostering trust among participants. It's important to note that this is a simplified explanation of blockchain technology, and the actual implementation and technical details can vary across different blockchain networks and platforms. Nonetheless, the underlying concept of decentralized, transparent, and secure transactions remains central to all blockchain systems.